The shown example is an electrical circuit, connected to one switch and indication lamp in a row. Once the switch is activated, power supply of 24 VDC is distributed to the indication lamp, then the lamp is on. Shown contact type of the switch is called normally open contact, or shorter NO contact. If it is not activated, there is no conductivity, and opposite. Similarly to this, there is an electrical circuit with different type of contact, and if the switch is in off position, the switch is connected, there is conductivity and the lamp is on. Once the switch is activated, it will disconnect the lamp from the power supply and the lamp will be off. This kind of contact is also called normally closed contact, or shorter NC contact. Now the same functionality can be done together with PLC. Switch shall be wired to the digital input module, since the indication lamp shall be wired to the digital output module of the PLC. When the switch is activated, the CPU reads status via digital input module, processes it by CPU, then sends command to the indication lamp through digital output module. Switch and the indication lamp are connected to the digital I/O, and the CPU maps these signals via addresses. Let's have a short recap of the procedure. First read inputs, then execute control logic by CPU, and finally, update outputs. Control logic in the CPU is done with the help of some PLC programming language, such as ladder, functional block diagram, statement list, or structured control language. Hello, I'm Tom, your virtual instructor. Stay with me until the end of this video and you will learn what the ladder programming language is, and how to use it. Ladder diagram programming, also called ladder logic, is a graphical programming language derived from the diagrams used for electromechanical control circuits. Let's look now at one set of ladder instructions. Shown two objects are ladder instructions. At the right side is one NO contact used to check status of some memory location. Then at the right side is the coil symbol used to write some result of logical operation to the memory location. A set of ladder instructions is called network. Even though a network in a LAD program is an arrangement of computer instructions, each network is said to control power flow from the power rail. In programming terminology, this examination of logical conditions is called solving the logic, and the solution of a configuration of instructions is called the result of logic operation, or shorter RLO. The ladder instructions are marked with letters A and B that represent a programming variable. After execution of these instructions as result, we get that value B is equal to value A. Each programming variable or PLC tag beside symbolic name, in our case A and B, has also address of memory location. So instead of assigning letters to the ladder instructions, they can be populated also with address of memory location, whose status value is read or write depending on instruction. Here we notice that it is a digital signal 1 bit long. Before we continue, if you like this video, click the like button down below, subscribe and bell. To better understand simple ladder instructions, there is the same logic presented as electromechanical control circuits. Once switch A is activated, then lamp B will light up. In the second example, we noticed that there is a new instruction at the position A. It is normally close contact. In terms of logic, it will invert the value of the assigned memory location and transfer to the coil. So if value A is false, it will transfer value true to the coil B. Same logic is done as an electromechanical control circuit presented at the right side. Now we can have a look at more complex logic instructions. So below the variable a there is a parallel branch with variable c, which represents logically, or, instruction. Next, in this example there are two contacts in row that represent logically, and, instruction. So there are many variations and it is possible to combine many logical instructions to satisfy requirements. The networks are numbered beginning with the top network, starting from network 1. As the CPU executes the user program, it scans each network from left to right and from the top to the bottom, cyclically. If we have a look at the several networks together, it looks like a ladder, so that is why it is named PLC Ladder Programming Language. The instructions shown in this video are only several of the many types of instruction that can be used in PLC LAD program. A LAD program can include a variety of basic and extended instructions. In TIA portal, instructions can be found in the instruction library grouped by categories such as bit logic, timers, counters, math, etc. Instruction can be inserted to the networks with simple drag and drop. That was it for now. I hope you've enjoyed this video. Have a look at the other videos from the channel. See you next time. Bye.